Okay, so this is the Titration Lab, and we've labeled our 100 ml beakers. We've taken approximately 60 ml of each solution, sulfuric acid, which is approximately 0.1 molar, but we're going to find out what the concentration really is, and sodium hydroxide, which is 0.275 molar. And so that's what we've got in our beakers. Now, one of the things you need to do is prepare your samples. And so we'll have 4 samples in these Erlenmeyer flasks. Hopefully you can see those. And the first thing we're going to do is use a volumetric pipette, which has a single graduation on the narrow neck. And we need to equilibrate the glassware. What that means is rinse it with the solution we're going to be using. So we'll just suck up a little bit. If you touch it to the bottom, make sure you tip it over a little bit, like that, so that it doesn't vapor lock on the bottom. And you use a pipette bulb like that, squeeze bulb, being careful not to draw the fluid into the bulb. So, we draw up approximately half of the pipette. So maybe you can see it, touch the tip to the point, and so you can see it in there. And we let it draw towards our finger a little tiny bit, not much. And we roll it around like that, and we drain that into the waste. So this can go down the sink. The products of this are just an ordinary sea salt. Not sodium chloride, but sodium sulfate. Anyway, so that's equilibrated. Normally you would do that 3 times, however, for our purposes here in Chem 12, that's once a... Okay, well, that sample's ready to go. I'll do another one because my video quit on me. Battery wore out. Okay, so I'm going to draw up my fluid above the single graduation and let it draw down. So, tipping the pipette over, drawing up beyond the single graduation, careful not to get it into the bulb. Whoops. Sometimes that's hard to catch when you let go. And touching to the side of the container, hopefully you can see the graduation, I let it drain down so the bottom of the meniscus is on the single graduation. Just like that. And now I touch the tip again to the side of my container, my Erlenmeyer flask. Hopefully you can see that. And let it drain down. And so these pipettes are 10.00 mils, plus or minus 0.04. And it's to deliver in 11 seconds. Which means once it gets to the bottom and you think it's empty, wait 11 seconds with the tip touched to the side. And at 20 degrees Celsius, that's 10.00 mils, plus or minus 0.04. Anyway, so there it is. I'll put 1 drop of phenolphthalein in. That's the indicator for our titration. And now I'll equilibrate my burette. Okay, when you first get your burette, the valve is open. That's the valve right here. They've all been serviced recently, so they should be pretty good, but you might need to check this little nut here to make sure it's tight enough. It doesn't have to be too tight, but if it leaks, you want to tighten that up a little bit. Anyways, when we go to put fluid in here, make sure you close this valve so it's straight across the glassware. Anyways, and we're going to put about 5 mils-ish sodium hydroxide in here. And I'll roll the barrel of the burette as I do it. Okay, so maybe you can see that there's some up in here. It's on the graduations. Now, I need to, so this is the rinse, the equilibration. And so I'm going to turn the valve on full blast and it'll fill up this tip. And I might have to shake it to make sure the bubbles come out. Uh-oh, didn't have enough. Still have some bubbles. Get some more. You don't want to waste too much because we don't have a whole lot of extra. There's the bubbles going. There, they're gone. Now we close our tip. The tip is now rinsed, equilibrated, and full. So we close this, and then we dump this into the waste. The waste is the sink. This is the material that's found in Drano. Anyway, so it's fine to go down the sink. and we roll the graduated, or the burette, as we dump it out. And that is equilibrated. You'll notice that the graduations on the burette are upside down, and so that it counts from the top downwards, and this is 32, 33, 34, 35, 36, 37, and it's counting downwards. So when you're using it as a graduated cylinder, excuse me, you have to be careful that you're reading it correctly. Okay, now we're going to fill it up beyond the top graduation, which is up here. So beyond the 0 a little bit, and then we'll let it drain down to the 0, so the bottom of the meniscus is on the 0, and that'll be our starting point. So this is our sample. It has 1 drop of phenolphthalein in it. You must have that, otherwise it won't work. You want the tip of the burette about 1 centimeter below the rim of the Erlenmeyer flask. I'm right-handed, so I'm going to hold the Erlenmeyer flask in my right hand and swirl it the entire time I'm doing the titration. I might just slow it down so you can see what it's going to do temporarily. Since I'm using my left hand to control the valve, I want the valve handle, I suppose, on the right-hand side. I'm going to reach around the barrel of the burette with my thumb on the white part and my 2 fingers, these fingers, on the blue part of that handle. And if you put a piece of white paper, which is going to be waste, it might have drips of fluid on there, so we're going to have to throw that in the garbage later. It'll just show up the indicator better. Okay, so here I go. I'll just not swirl it for a second so you can see what will happen. See the pink color? That pink color is the indicator changing color. And so that when I get to the end, that pink color will stay. So swirling the entire time, we'll add some of the base. This is our known. And notice that it does disappear. When the pink color starts to persist, then you want to slow down. That's sort of persisting right there. And so I'm just going to add drop-wise, so slowly. Whoops, that's it. I overshot it a little bit. I think I'm probably 2 drops out. Anyways, so that's the end point. That's what you're looking for. You can get it within a drop if you're really careful. Okay. So download the handout from the course website, and I'll give you some data, and you can do the lab.